Welcome everyone to the Correlation Topology webinar. We have spent thousands of hours to develop this feature, which we're going to take you through today. This is a early presentation of what is being released in the next few weeks from AIMS. So today you have Marius. Are you there, Marius?
Hi.
You want to say hi?
Yes.
Marius is AIMS CTO. He's the beautiful guy with the blue head. My name is Ivar. I'm the robot with the yellow head in this avatar. We have a handful of slides for you today. I believe that's going to be covered in about 5 minutes. And then we're going to do a real live correlation topology demo, about 15 minutes. And then we're going to hand this over for a Q&A. This webinar is being recorded and will also be shared to everyone that has signed up, and will also be published on our website. Participants are muted by default, and please submit any questions you have in the Q&A pane in the Livestorm application. We are making the correlation topology available for early access requests. You can follow this link. I believe it will also be published in the Q&A or comment section in Livestorm for anyone that wants to sign up for a early access. So with that, the pain that we're trying to solve with the correlation topology is something that many companies, service providers are already facing, and that is the complexity of IT systems, IoT devices, data, interaction, dependencies, and relationships between any kind of system sitting on premise. It could be industrial systems, it could be cloud systems, it could be microservices, applications, and infrastructure. Increasingly, these systems interact in some way, and that creates a massive challenge with regards to understanding what's really going on. So we see customers facing the pain of understanding the environment and its dependencies. How can they actually be proactive with this complexity? A lot of our customers, they struggle with setting static thresholds in traditional monitoring tools, ending up with a bombardment of alerts, which really doesn't work in a modern world. How do you control SLAs and in these systems that are really exposing business services to customers or end users for large organizations? And how do you actually investigate and troubleshoot these problems when it gets this complex? Where is the weakest link that impacts potentially a critical downtime? How can you expose dashboards and reports to users? And lastly, a problem that most of our customers face is that you can't just keep adding or hiring people in IT operations to solve this complexity. You need to do something smarter. This challenge has been faced by a lot of companies already, and it's going to be a bigger issue moving forward. This is a picture of this is Heathrow 5, or I'm not sure if it's 5, but it's Heathrow Airport, and it's the line at the check-in when BA had to shut down every single flight in Heathrow and in Gatwick throughout the whole weekend because they were not able to check in passengers, and this was due to a small glitch in the IT system. So that's just an illustration of the potential pain small issues can impact for a interconnected IT environment. This market is also supported by the analysts. So Gartner defined this market in 2017 as AI ops, so using artificial intelligence for IT operations, and they claim that AI ops will transform businesses or IT operations over the next few years, and there will be a massive growth in take-up of AI ops from 3% today to 30% in 2024. Further, Forrester are basically supporting Gartner and stating that the complexity of IT systems means that IT operations team have to look at a different kind of tool sets than they have been using so far. At AIMS, we have spent several years developing a solution for this challenge, and it starts really with capturing a lot of time series performance data from different kind of systems. Today we support, we have built proprietary AIMS performance agents for a set of Microsoft-oriented enterprise servers. And then we're opening our whole platform really to any kind of time series data, which also now includes Influx Telegraph performance agents, which supports more than 200 additional technologies. Anything from Oracle to Linux servers to containers and network, in addition to the application service layer across on-premise and cloud environments. So we capture performance data through a flexible API. We normalize or aggregate the data. So we're cutting and dicing the time series performance data into different frequencies that we use algorithms to analyze. We discover topologies based on that data pattern or that behavior, and we identify anomalies based on learning what's really moving in a customer's IT environment across all the systems connected. And the output is basically anomaly alerts that lets you monitor, it's dashboards that lets you govern, and it's topology with knowledge that lets you understand what's really moving and going on. And today we are going to discuss this topology discovery. And that's where we are handing this off to a live demo. So from now on, Marius, this is showtime for you.
Thank you. Yep. So I guess you see my screen.
Yes.
Yes. So coming into the AIMS UI, you can see that we have three different topologies currently. We have the physical, we have the correlation, and then we have something called systems view. Starting in the physical, the user can see a representation of all the systems or agents or agent types connected, and their AIM score, which is represented to the left on these nodes. And also the status of the anomaly. So the bar on the right is the number of different anomalies detected on the different nodes, their criticality, and also how many healthy metrics that are connected to a single node. From all the system types that we currently see surrounding this center node, the statuses are accumulated into the environment node, which then again will provide kind of like an overall status for everything you monitor. So the AIM score that you see on this center node, that's an aggregated score for your whole environment, meaning that you can see the complete health status of everything that you have connected to your AIMS environment. The AIM score is a proprietary score developed by AIMS, and it provides a value between 0 to 100 to represent the health of the node that you're looking at. And the score is calculated based on anomalies, meaning the more anomalies or instability a node has, the lower the score. So let's see what we can find here. Just a second, I'll try to navigate to something I want to look at. I want to take a look at SQL stored procedures here. Also, the representation that we're looking at here on the physical topology is coming from the different agents that you have connected to AIMS. So surrounding the center node, as you see here, you can see different agent types that we currently have connected to this environment. We have Windows servers, we have SQL, we have Azure Agent, and so on. So the representation that you're viewing here is coming directly from the agent. So let's take a look a bit further down here. Let's say I find a node that has very low AIM score, and I want to investigate what kind of dependencies this specific node has. I want to see what other components or systems or applications that might depend on this node. So this is where the mathematical correlation engine of AIMS kicks in. It will automatically discover and update these dependencies daily. And by clicking this button here, I can navigate, or a bit later, I will navigate to the correlation topology. But as of now, I'm looking at one specific stored procedure. I can see how many anomalies it has, and also how many correlation group it belongs into. So no manual instrumentation or setup is necessary. AIMS will automatically use all available data to detect and classify dependencies between individual components, applications, and systems. So what we're looking at now is a so-called correlation group. It's the discoveries that the AIMS correlation engine has been doing. It took the DB ignore open event sync, which had a low AIM score, and I can now view all its dependencies based on the mathematical correlation engine that AIMS has.
So Marius, just to chip in here and disturb you a little bit. So this is not relying on anything else than the data, performance data we fetch from the systems, right?
Exactly. So you don't have to instrument anything. You don't have to do any manual setup. It takes basically all the data coming from the agent. And based on that, we can see if there's any dependencies on a specific node or system or application, and we can highlight these dependencies being discovered in these correlation groups that we're looking at now.
Which basically means that there's no massive project or as long as you get the data in, this is just the algorithms doing
exactly. The rest is completely automated. Looking at correlations between individual components, as we're doing now, can, of course, be very interesting to investigate performance issues, scaling, architectural problems, interchanges between systems and applications. But also correlations found by AIMS can also be used to visualize dependencies across systems and applications. So let's go to this one, system correlations. Sorry, I have this already popped up here. I've been cheating. For instance, a common situation these days is an enterprise gradually moving or creating new services in cloud, but still depending on classical on-prem hosting. And AIMS can then be really useful in visualizing dependencies, as we're doing here, across cloud and on-premise. As you all know, this is a rapidly changing configuration and setup. See what kind of cloud services are depending on systems on-premise and vice versa. So based on all or every single node that AIMS is monitoring, meaning that we can do CPU cores, we can do a store procedure, as I was recently doing. All this information we can bubble up and place within individual systems. And again, based on that aggregated information, we can draw dependencies between actual applications, systems, servers, and so on. And this is what we're looking at here. So on the sides here, you see actual system names, server names, application names, and so on. And by going in here, I can see what, so for instance, this AIMS USE influx, I can see it's connected to this server up here. And this is done without any instrumentation or pre-knowledge about the setup. This is just discovered by AIMS automatically. And I think that concludes my demo. It's not 15 minutes, but still.
Marius, can I ask you a couple of questions when you're on this? So if we take this back to that, so what you referred to as the pineapple, which was sort of the the challenge of customers with all systems connector and trying to understand what's really moving, what's the dependencies, what's anomalies. You can't really scale IT operations to understand this complexity. So looking at this from a user perspective, you want to understand anomalous behavior in your systems, right? And then you could technically either start looking at the physical correlation view you were in, right, and navigate this way. And what you're seeing here, I would say, is you can see anomalies and then what kind of systems it could potentially impact. So bringing that back to the British Airways scenario, right, where the British Airways weren't able to check in passengers through their kiosks, right? You could technically be able to understand what was the cause and the root cause for that happening, right? And be able to prevent it before maybe it escalates to that kind of situation. Is that correct?
Yes, that's correct.
Okay. That was pretty cool. So let me go back to this presentation, and before we move to the Q&A, want to quickly just touch on this early access to the correlation topology. So this form is published on our website. It is a way to get an early notification of access to the correlation topology. Keep in mind that AIMS is available for everyone to try out by simply registering on our website, so that either to run it as a limited community edition version, but also by signing up here, you will be able to test out the correlation topology for free. So with that, I think we're going to turn this over to the Q&A section. So I think it's time to take a look at what has been submitted.